I have multiple videos on how to create React applications using Vite for server-side rendering, with each approach getting subjectively easier and easier. So unless you are perfectly content with these approaches, or you're perfectly content with Next.js, today I have an even easier way for you to spin up a React server-side rendering application. Let's take a step back for a little bit of background. In 2019, if you wanted server-side rendering React, your choices were limited to just Next.js. And then a couple of years later, Remix was available for public use. Today, we can use other technologies in combination with Vite.js to create server-side rendering React applications. Let's take an even bigger step back to the year 2014 when React Router was made available to the public, which is only a couple of years after React itself came out. Until 10-stack Router came out recently, React Router was the de facto React Router library for React. React Router have had over 2.5 billion downloads from NPM repository. What may surprise some people in the industry is that the team that created Remix is the same team that created React Router. Some of you may be familiar with Shopify, the $9 billion e-commerce company. In the last couple of years, Shopify has bought the React Router product as well as the Remix product, keeping these teams employed and adding personnel to the development team of each product. It's the same concept as Facebook owning React, Google owning Angular, and Vercel owning Next.js. There has been a concerted effort to combine the features of both libraries into one, that being React Router, the latest incarnation of which is version 7. React Router gives you choices. You can use React Router as a classical single-page app routing mechanism in declarative mode. You can use React Router to fetch data without use effect hook or 10-stack query or any data fetching library. I have a video on that for you. You can use data mode for server-side rendering or client-side rendering, your choice. Now the framework mode is the full enchilada, but even with that, you can also have the option of choosing server-side rendering or client-side rendering. Now with Next.js, you do have the option to client-side render part of your app, but I would have to say subjectively that that option is a bit smoother in React Router v7. This is what we will be building in this video tutorial. We are going to build a completely server-side rendering application. All aspect of it will be completely SSR. We are fetching data on the server side from a dummy JSON library. We're just fetching 10 products, and when we clicked on each product, it will go into product detail. And of course, we go back, and then we have the option to add a product, and then we will post product to the endpoint, a real endpoint that is free to use from the server side. And then I'm going to walk you through the deployment process, This application is deployed to Cloudflare. I will also walk you through deploying the application to Vercel, which is the competitor to Cloudflare, so that you can have a couple of choices, and this application works the same. Everything server side. We will deploy the application to both clouds using the command line. If you're adverse to using the command line, I will show you how to just use GitHub. So how do we prove that this is indeed server-side rendering? One way is to view page source. Now that's view page source, not inspect, okay? As you can see here, the server is showing up the entire HTML. Another way is to open up our Chrome DevTools or any browser that's Chromium base. And then in the developer tools in the browser, we go Command Shift P, type JavaScript, and then click on Disable JavaScript. As you can see here, we got a little warning here that says JavaScript is disabled. In a client-side rendering application, and you disable the JavaScript, it will not work, other than just looking at the HTML, but you will have no interactivity whatsoever. But this is a server-side rendering application, so we do not need JavaScript to do our work because it's server-side rendered. And if you're very astute, you notice that the page refresh, right? This is no longer a spa. This is a server-side rendering application, so that's why we're getting the page refresh. So this is a server-side rendering application. So what are the benefits of a server-side rendering application? You might have noticed that the tab title in the browser have changed when I navigate to certain parts. For example, here at the landing page, because I'm limiting the API to just returning 10 products, it's showing here 10 products available. That might come in useful. Also, when I click on an individual product, the tab title in the browser matches the title of the product. And if we were to inspect, we say that in the DOM, in the meta tag, in the content attribute for description, the content attribute text matches the description. I've set it like that. You can imagine how useful that could be. Of course, React Router empowers you through easily applied functions to do this. You can see how it can be immensely useful and easy to use. If I can do it, so can you, right? And same thing here with the add product section. Now, if you watch my Vike, Vike is the Norwegian pronunciation. People can call it Vike, but I have a Vike video, and they offer the same thing as well. Now, Vika is a very good library. I think this is even more elegant, and as you will see later on, it's actually easier to apply, just as easy, if not easier to apply than in Vika. If I have not implied it already, when you use React Router in the whole enchilada framework mode, it leverages Vite. And so as such, the way that you spin up a React Vite server-side rendering application using React Router are many foes. You can spin it up using the create React Router CLI command, or you can just spin up a regular Vite React application and then selecting React Router. Here's what I mean. I'm running the command pnpm create vite at latest. Of course, I've alias pnpm, which is pn for less keystrokes. And then I would select React, and then I would select React Router v7, which would automatically scaffold up um, a React Router application for me uh, with TypeScript and Tailwind by default. And by default, it has the whole shebang for framework mode. And then this command here, provided by the React Router team, will do the exact same thing as I just demonstrated in Vite. You prefer to use pnpm instead of npx, you can run the command pnpm dlx and then the rest of the command. You can say that all roads lead to Rome in this case. Oh, and speaking of Rome, salve amicus. Let me know in the comments if you know what this means in classical Latin. And did you happen to notice my 5 icon? That's the Princess of Darkness herself, gracing us with her presence. It wouldn't be a good tutorial without at least one Taylor Swift joke. And per usual, I will have GitHub repos for you for this tutorial. I have one for deployment to Cloudflare and then one for deployment to Vercel. Now, I could not have both deployments in one repo, different branches, because of the way that Vercel works. But anywho, you have completed projects for both clouds. When I said that framework mode was the whole enchilada, I wasn't kidding. Aside from the aforementioned two ways to spin up a React Router server-side rendering React app, they also have deployment templates for you to set up your app with, including Node with Docker, custom server, Node with Docker and Postgres, Vercel, of course, uh, Cloudflare with workers, uh, with D1, which is their database, and then Cloudflare workers and Netlify. The one that I will be using is Cloudflare workers. We don't need the database. We don't need D1 because we have our own API already. So we'll be using this one mostly, and then I'll walk you through Vercel. And this is for people who don't know what an enchilada is. Here I am in the terminal. I issue the command pnpm dox, which is the equivalent to npx, and then the command that they uh, provide for us, standard installation. So here's what running that command gave us. React Router, React, of course, Vite, Tailwind. I updated Vite to the latest version, and of course the type for Node. And I installed Biome. I use Biome instead of Prettier and ESLint, or I should say in lieu of Prettier and ESLint, because Biome does the work of both of those libraries. And my VS Code is configured to use Biome for linting. Um, so the great thing about using Cloudflare and this template is that essentially Cloudflare is already set up for us. You see this Wrangler file here. Wrangler is the command line interface tool for Cloudflare. All we have to do now in terms of Cloudflare is to go ahead and set up a free account. if you already don't have one. If you have one and you have free account, great. Um, but you do not need a domain for this tutorial. All you need is a free Cloudflare account. Once you have your Cloudflare free account, let's peruse the documentation for Cloudflare in the Wrangler section. And you would install it just like you would install any npm package. Here's they have good instructions. The thing that I love about Cloudflare, and I gush over them, is that you can install Wrangler as a dependency in the project directory or the project folder. You do not have to install it globally, uh, which is nice, unlike Vercel or the other clouds. So this is wonderful. And installing and setting up Wrangler is ridiculously easy in our case. Once you set up your Cloudflare account and configure your Wrangler CLI inside of this folder according to the documentation, you can deploy your code to Cloudflare without going through GitHub. In fact, you do not even have to set up your workers in the Cloudflare UI like in other projects. You can do it all from the command line, from here. Um, so you have this worker configuration file. This is for Cloudflare. Of course, you have this Wrangler um, JSON configuration here as well. And then if you look at this deployed command within the script that React Router template provided for us, they have a built-in Wrangler deployed command for us to run. Yes, this says npm, but you can still run the command pnpm deploy, and it would do all the work for you. You do not have to connect your Cloudflare to your GitHub repository like in other projects. To demonstrate how easy running the Wrangler CLI tool from Cloudflare is, so currently I am running the app, the basic app that React Router gives you when you use that template, right? It's like a hello world app. And I'm running it in localhost. And then to verify in the browser, I'm localhost, port 5173, which is the Vite port that it listens to. And here's the basic um, scaffolding application. And then when I issue the deploy command from my scripts, as you can see here, it does the normal build and compilation process that you can see here. Wrangler's doing this thing. Of course, at this point, I have a free Cloudflare account and I've set up Wrangler CLI tool locally in this directory. Okay, it's giving me a table of what's happening. Very good information, the normal build stuff, yada, yada, yada. Success. Okay, it gives me useful information. And then it gives me the web address of the deploy app. Of course, I didn't pay for a domain, so they'll choose the name of the URL for me, right? When I click on this, it takes me to my demo app, which at this point is just a basic Hello World app that comes with the React Router Cloudflare template. Obviously, for serious work, I would want to have version control and all of that, but I got my app deployed from the command line without involving GitHub or Bitbucket or any cloud get services. If you've been a professional developer for a minute or two, you understand how immensely useful this process really is. Because there are certain times when you want to see your app in the development process outside of your local environment and have it up in the cloud to see how it interacts outside of your local dev environment without having to go through the whole rigmarole of issuing a pull request and having to go through that process because you might not be ready to have a pull request issue quite yet. You might still be in the experimentation phase. Or if you have a spike task, I think it's a pretty fair trade-off to have a few extra files in exchange for seamless deployment to the cloud. In terms of the actual code files itself for this project, the files in the app directory, public, and of course the React Router configuration. Now, I mentioned earlier in the video that we have choices when it comes to whether we want SSR, server-side render, or client-side render. If you do not want server-side render, I would recommend not using the framework mode, okay? Because all this is overkill if you just want a client-side app. So it wouldn't make sense to flip this to false. However, within this application, even though it is by default server-side render, there are certain mechanisms that can make part of your app client-side render, just like in Next.js. But I think the process in here is much more elegant and easier than in Next.js. I'll demonstrate that in a bit. Let's take a closer look at what's inside of the app directory. Let's start at the routes file. In here is where we define and configure our routing and decide which route goes with which component. So essentially we're maintaining our state, our application state in here. And the component that aligns with certain part of the root of our app, or those component has to live by convention, only by convention, inside of this routes directory. And so directory components that has a relationship with our routes in here, those component goes in here. And the components, like for example, this welcome component, where it does not have a relationship with the routing system, it can live outside of the component directory. So it's down here, that's just basic CSS. By the way, in case you're wondering why there are squiggly lines here, my biome is detecting the fact that these imports are not in alphabetical order. Being in alphabetical order makes it easier to read. So I have it configured to where if I press Command Save, it'll automatically sort out the imports for me. And that is something that I've configured inside of biome and with my VS Code for biome. Let's examine the entry server file, which is absolutely critical for server-side rendering operation in a React application. This handle request function is what is actually processing all incoming HTTP requests and renders the React application on the server before sending the HTML to the client. Again, this is absolutely critical for server-side rendering performance and search engine optimization. This ensures that the React application render correctly on the server before reaching our browser. What's doing the heavy lifting in this function are the render to readable stream module from the core React DOM server package and the server router from React Router library. Of course, these two are just types. But essentially, these two modules are doing all the heavy lifting in this function for server-side rendering. I'll get to isBot here in a second. As a basis of comparison, I wrote this application last year for React server-side rendering with Vite and the old version of React Router. And at that time, we did not have render to readable streams from React Router. But conceptually, it's similar, but you have to write more code. Obviously, I'm importing in other things into the entry server file, but you end up doing more work, and it's not quite as elegant as what React Router v7 is offering now straight out of the box. If you notice that in the package.json file, we pull down the isBot package, and then we use that in here. This only helps with SEO. There are multiple type of bots in the World Wide Web. They scan, they crawl for different things, for ranking, for SEO. This package only helps with SEO. Now, there are bad bots as well. There are bots that are programmed to find vulnerabilities in your application. This package will not stop that. This package, again, is only for SEO. So your application, whether it be server side or client side, still needs security measures in place. Of course, this being a server side, I feel like we have a little bit more control. Finally, in the app directory, we have the root file, which essentially contains our main layout. If you worked with Next.js, they have a similar concept, but I feel like theirs is a bit more complicated than it has to be, certainly. Um, and then you can go in here and modify it if you need to for our demo application, which we will be building together here shortly. We do not need to modify any of this stuff. We also have an error boundary here as well, which handle all the general errors in the application. And then we can add custom errors on top of this. Before we build our tutorial app, I'm going to whack home and welcome. Inside of app, I created a components directory, and then inside of the existing root directory, I created a products directory. We will be fetching products from the dummy JSON free API. The products that you see previously in my demo comes from here. This free API also have a post route where you can send your post request to, and return it will return an object for you if there are no errors in your code. So this API here handles full CRUD functionality and then some. ultimately, I would like our app folder structure to look like this. Of course, we have this is a TypeScript application, so we have our types for our products in here. But this pattern here you see before you in terms of folder and file structure is very common, a very common convention among React server-side rendering application. And I think it got its start with Next.js. Um, and by convention, I think this is a good convention to have because it makes a lot of sense, at least to my dark and twisted mind. But this is something that I want to keep from Next.js because it works well for us. And of course, in the public directory, we have the Princess of Darkness 5 icon if you want to use that. This well-known this well-known um, subdirectory in here is a solution to a problem with the Chrome developer tool. And just to give you a high overview, I'll get into the error later on, but when we install React Router, in the dependency, we have the React Router itself, but in the dev dependencies, we have this at React Router dev package, which primarily works at the development environment to make life a little bit easier for developers. And the Chrome developer tools is choking on this package, on a very small piece of this package here, but I have a solution for that. I actually made a separate video about that, but I'll go over this issue later on. Under the app directory, I've created a directory called components. I added an empty file called Navbar, and then under the roots directory, I've added another directory called products with an index root. And then under at the base of the roots directory, I created its own separate index. So this index here is for the roots directory, and this index here is for the products directory. Let's start at the reusable components level with the navbar. Now, the type for the navbar props will go into the types directory, but I want it to be here so that you can see it without having to flip back and forth. Let's have a look at the finished tutorial application and look at the dynamic conditional rendering of the navbar. So at the landing page, the only thing I want to show is the products link. And when we are at the products landing page, we show home and we show add product. And from the add product page, we show going back to products. So I have it to where the links that shows up in here depends on where you are in the application. So that is the reason why I have the boolean here to check which view we are currently at so that we can render the proper links within the taskbar. Now, Tailwind CSS is an amazing library, an amazing CSS tool with all of their utility class, but showing all the utility classes in a tutorial video can be kind of distracting for the viewer. So I'm showing the code for the navbar without all the utility class. Of course, the Tailwind class will be added back on uh, later, but I'll try to do this with all the code in this tutorial. But essentially, we have conditional rendering of the links within the navbar, just basic JavaScript, TypeScript logic. Now let's use that navbar component. So in the roots directory, go into the index file for the roots directory. Okay, so in there, import the navbar like you would any other app. We'll create a component, a React component called welcome. I'll tell you why we have this prop here in a minute, but then we'll fill in the text. Let's have a quick look at the React documentation. I know you guys would rather watch a video than have to pour through hours and hours of docs, but sometimes it's worth it just to look at uh, the documentation real quick. So for server-side data loading, React Router provide us with a loader function which we have to implement ourselves, following their model, following their pattern. But we need to create a loader function which works to not only load data but also to navigate between routes, as you can see here. So any component that will be that will have a relationship with React Loader is used for state or for routing purposes needs to have a loader function inside of that component. The loader function for this page is going to be very simple because it's just a landing page. I'm going to be using it as an index once we configure our routes down here. But what I want to do here, since it's a landing page, is I want to test that we are indeed uh, in server-side rendering mode. And aside from view page source and turning off JavaScript, essentially I am returning this message here. And that's why I have this SSR prop here. And so if we are in truly server-side rendering, then I want to render the the SSR is working message in the HTML when we view page source, just to verify. Now, if you weren't doing any of this stuff and you need this as part of your component state, or part of your routing system, what you can do is you will need a loader obviously, but you can just return null. Okay, so let's test this out. Before we can see that in the browser, let's go ahead and go into our routes file uh, and change this to index. Okay, I'm running our app on localhost. We don't have a link to products yet. That's okay. We'll do that. We'll implement that later. Now let's do a view page source. Let's look for our string. There it is, right? You can tell here too that this is server-side render, right? I mean, it's loading up all the HTML. Now you won't see any XHR um, in the network tab because this is server-side rendered. And I've removed the Taylor Swift 5 icon. For now, you're welcome. One more important item before we move on to the next section. Remember when I was raving about React Router's ability to dynamically add metadata? Well, the library provides us with this function as a basis, and then we can make this dynamic if we wanted to. And I will show you how to do that a little bit later. But here I'm just supplying static data for the title of the tab in the browser to be this value here. And then this part here will inject the meta tag in the head section with the description and what's going to go inside of the attribute um, in there. So when we actually fetch data from the API, we can make this more dynamic. And just to verify, in the title of the tab, we see computer science for everyone, and then inspecting the metadata here, content that. So this pattern here, the pattern in this very simple component is pretty much the pattern for fetching data for server-side rendering in React Router v7. It's a very simple pattern. Of course, this is a video tutorial, so I'm over explaining everything for my very wide audience base, but it's very simple to implement. If you've been a web developer for a couple of minutes, uh, you can grasp this concept pretty quickly. We have a loader, we have a component, and if you want custom metadata, you call you implement the meta function, which is patterned after what's inside of the documentation that they give us. So, and then if we were to post data to the API, instead of having a loader, we'll have an action. And then for posting data, I know I'm getting ahead of myself here, but for posting data, the React Router library even provide us with a form. So we don't even need React hook forms. So this library is an inclusive library. It gives you a lot of stuff out of the box. Now, obviously, there's 10 stack router, which is great as well. So, but this is also good. So they're both great. You just have to decide which one you like better. What I meant by a wide audience base is that my audience have different backgrounds, different skill set, different skill level, different jobs within the industry. So that's why I'm over explaining things. Also, I would like to take this opportunity to ask you to please subscribe to my channel and give this video a thumbs up if at the end you find it beneficial. I don't make any money at all currently from doing this. I'm asking for subscription, which is completely free because in the future, perhaps YouTube will give me something. Thank you. Now that we have our index, which is our landing page, our base route or index route, let's go and fetch some products in the products subdirectory, and we'll fetch products in this index for the products subdirectory. Let's go back to the docs real quick because I want to talk about the hook that we are going to use to fetch data. And that hook is called useLoaderData. And speaking of documentation, so there's this documentation, uh, which is based off of the installation and the landing page for React Hook and all of that. And then the hooks are organized on the left here in the nav section by hooks and by components. And if you were to click on this reference documentation here, it'll take you to this page, uh, which goes into a little bit more detail. And then you were to click on the define in, that'll take you to the GitHub repo where you see the actual code. Remember when I was telling you that the router now controls the state, and each piece of a route, each portion of the route or a route control a part of the state, right? So look at the way that that hook function is defined here, is created here. This is why you don't need uh, use effect hooked or any other libraries to control your state and to fetch data. So in the index file for the product subdirectory, I'm bringing in the useLoaderData hook. I'm bringing in the navbar, and if we were to follow the established pattern that I mentioned previously, we are going to have a loader function that will fetch or load the data for us. Dummy.json was where we're going to fetch the data from. The API allows us to limit how many items we bring back so that we don't overwhelm the bandwidth, and we can also be selective in what items we bring back from the endpoint. Just to make things clearer, here I am in Postman. I'm fetching data from the dummy.json API, from the products endpoint, and with the limit and being selective of what I want to bring back from the API. As you can see here, I'm only bringing back things that I need: ID, title, and thumbnail. I know that's kind of small, but just bear with me. If I did not have this limit, this will be what you get back. As you can see here, this is a lot of superfluous data that we do not need for this tutorial, right? So therefore, that's why I apply the limit and the query string param. We will then do some error checking, await the response, cost it, and then store it in this data constant. Now, some of you TypeScript guru out there might be asking me why I'm not using a generic instead of costing the response. Well, the reason is because I want to cater to every cloud vendor out there, to include Cloudflare, Vercel, Netlify, what have you. And this syntax has been around for a while. And I'm not sure, based on my research, if the cloud vendor is supporting this syntax as of yet. Who knows? That might change next week. Things move very quickly in the JavaScript world. But in order to placate all of the cloud vendor as of the time of this recording, I'm going with this syntax whereby I'm costing the data. And then of course we return the data in the function. And if you're wondering why it's data dot products, that is because the API returns an object with a key of products, and then the value of the key products is an array. So that's why we do the data dot products. So we can loop through here, through this array of objects. And again, I'm only showing the type here so that you can like equate what's type I'm using rather than have to switch back and forth between different files. The reason this is an interface instead of a type is because you might want to extend this later down the road, but ultimately all the types will go in the appropriate types file. Now that we have a loader function fetching our products from the API, let's use it inside of our products component. So we'll declare a constant here called loader products, which is referring to this loader here. What is it loading? It's loading our products. In the future, if we were to say have a price loader, then we call it loader prices. And then we use the useLoaderData hook that React Router gives us to access the data that was fetched in the loader function above. Please keep in mind that the loader function runs on the server before the component renders and fetches products from the API. And then the product array generic tells TypeScript compiler that we expect an array of product, an array of objects. And then we can use all those wonderful JavaScript and TypeScript array methods on the data. Of course, TypeScript is just syntactic sugar for JavaScript. And then on line 33, I'm using a JavaScript knowledge coalescing operator, the double question mark, to establish a fallback pattern. So if the products prop exists and is not null undefined, then use products. Otherwise, fall back to the loader products, data from the loader, establishing the data for this component. So all the component that is accessing this data is accessing through here, provided. On line number 33, I'm using the JavaScript double question mark operator, which is the JavaScript knowledge coalescing operator, to establish a fallback pattern for when if the products exist and not null undefined, then use the products that's passed into this component. Otherwise, fall back to the loader products, which is being fetched from the data from the loader function above. And the reason why I'm using the notice coalescing operator here is because um, it only falls back if the value is null or undefined. Null or undefined. If the value is falsy, like zero empty array, for example, zero or empty array, these could be legitimate values coming back from the API. If somebody deleted all the data for some strange reason, then it could be an empty array, right? Again, this operator only checks for null and undefined, right? It won't throw an error if it's zero. Again, somebody can delete, or if we sold all the product, then we have zero quantity left, right? So this could be a legit value here. And then we'll bring in the navbar, and then we loop through the data and bring out the individual products for the products page, which is the landing page for our products um, route. But let's pump the brakes a little bit. Okay, that probably wasn't pumping the brakes. That's more like a screeching the brakes. Let's use the completed tutorial application as sort of like our Figma. And if you analyze this, these these are cards, right? These are cards. Each one of these products on the products page, each product is a card. And each card essentially is a link to the individual product. Okay? And what we're bringing back here for this is the thumbnail pic, the description, and the ID. And we're using that ID for navigation to the proper product. For example, this is ID of 7. So I think it would make sense to create a subcomponent called products card. Now, this subcomponent won't be used in multiple places, only in one place in our products component. But I think by dividing this up, we'll make our code for the products component easier to read for our teammates who will inherit the project later on. The products card subcomponent is easy to implement. We have a products card subcomponent here. We'll take in a product of type product, and then we'll have a list item um, of the whole list item will be a hyperlink, right? Again, we are using server-side hyperlink, server-side navigation. Let me sidetrack here for a minute. So React Router gives us a link component to link between different pages and different views. The problem is that if we were to use link in our code, then um, this would turn it into a client-side rendering component, and we will lose our SSR ability. Now, if that's what you want, remember the framework mode, you can go either way. If that's what you want, if you no longer want complete server-side rendering and you don't mind client-side, then by all means use link. But if you want complete SSR, then we navigate like so. Okay, and of course we bring in the image, thumbnail, and then the title for the product for the card. Of course, I remove all the styling to make it easier to look at. I'll add the styling back before we push. So to me, this looks a lot cleaner than having this whole piece of code inside of this UL, inside of this unordered list. Imagine what it would look like with all the stylings uh, for Tailwind class names, utilities class name in there, right? And then obviously React requires key prop, right? And then we supplied the key prop in here when we call this component. Okay, so we have our loader, we have our subcomponent, and we have our main component, and we have our Tailwind CSS styles. What are we missing here? If you're guessing meta, the meta function, you're absolutely looking at our improvised Figma. What do we have here in terms of metadata? So in the title of the tab, we have 10 products because we are physically fetching 10 products. If that changes in the future and we want 20 products, then this will say 10 products available. Now, what are we getting in terms of the um, description? There are 10 products available. So the number is dynamic and the rest is static. So this should be easy to implement what we know so far, right? So we know that previously when we implemented the meta function in the welcome page, we know that the pattern of the meta function will return the title, the name of the attribute, which is called description, and the content within that attribute. But here is unique though. Here, because we are trying to get the number of items that are available on that store landing page, we need to handle the case where what if there were no product? What if we were just sold out, right? What if we were sold out all the products or some sort of tariffs shipping issue? We need to account for that. So here's a pseudocode. If some condition where there was no products, then we're going to render this here. Otherwise, if there are products, then we're gonna do our magical metadata work. So how does the meta function access the data from dummy.json API? What do you think? It is saying from the loader function? You're absolutely correct. React Router makes it so that the meta function is capable of using the data from the loader function. And how it gets the data is from passing in an UGS parameter with the type of meta functions UGS. I've created this type here and made it an interface so that you can extend it if you need to in the future for other purposes. As you can see here, the optional data here is our product, right? It's a product coming from the products API for the products endpoint in the dummy.json API. So essentially, the meta function have access to the data for the component via this loader. So then by that logic, we can grab the data from the loader function. We'll assign it to a constant called product, and then we'll check to make sure that product is in the shape of an array. And then if it is, then we return the count, the length, which is the count. Otherwise, the count would be zero products. And then we'll assign this to a constant called count. And we will use that count for the title of the tab in the browser and then for the description and the meta tag. And then for this check, we'll turn the blah, blah, blah into if not product, then show this message. So this code file is essentially done. What do you suppose the next step would be? You are absolutely correct. We define individual root in this roots file, right? Roots, plural, we can presume that it will take individual root, singular. I'm trying not to roll my R's, as you can tell. But so the library provide us with a root component. There I go. I need to stop rolling my R's. I'm not sure why. Okay, so then we are going to establish the index root for products. Easy enough, right? Here, I'll just paste it in for you. Okay, so our products state will be this component, and it will be this root in our navigation. That's it. It's as easy as that. I told you this was going to be easy. Let's test it out in the browser at localhost in our project. Landing page, products, there we go. Okay, we have 10 products. We have not established add product. We have not established the individual product when we click on it yet, but it's all there. Okay, let's inspect to make sure that our metadata is in here. There it is. If you want more than 10 products, obviously you just go in here and change it to whatever amount of products. And then in the browser, we're going to get more than 10 products. In this case, 12. Interesting. I've never seen that before. I guess all of this stuff leads to bedroom time. That's interesting. Yeah, I wonder why that is. I don't know these things, people. I'm as pure as New York snow. Next, we'll create the view for the individual product for when the end users click on the individual cards. We'll call it id.tsx, and the word ID is wrapped by the square bracket. Now, if you're not familiar with this syntax, officially in the React Router world, it's called the dynamic root parameter syntax. The ID within the square brackets means that it's a dynamic root segment. So for example, when you get products /1, the ID param or parameter would be equal to 1. Okay, and give you another example. If the product /17, and then the ID parameter would be 17. Obviously, it doesn't need to be an integer. It could be like, bacon, and then this would be bacon. All right. Now, this syntax actually came from Next.js in the previous decade. The pattern for this file is a familiar one. Uh, if we were to consider what we did previously, so of course we have the imports, and we'll need our types, and then we have a meta function, a loader function, a component function. The only tricky part, if you can call it that, is how we will extrapolate uh, information from the API to be used for a metadata, and I'll walk you through that. The loader function is established pretty much like we did before, except we'll take a param of type ID, and it'll be a string. And then we are going to fetch the individual item based on the dynamic product ID, because the API's product endpoints allows us to fetch individual product based on its ID. So based on that, I hope it's clear now as to why we are using the dynamic ID segment for this file. So then implementing the component itself is pretty straightforward based on what we've already done. bring in the hook to use the data in the load from the loader. Now, in terms of the images is always going to be in the shape of an array. It's guaranteed from the API endpoint. So unless that endpoint or the entire API is down, the images will always come back inside of an array. So that's why I chose the first image in the array. Of course, we do optional chaining to make sure that it's there before we try to fetch so it doesn't throw some crazy error. So then it's pretty straightforward. And then I choose to add a back to product down here within the card. You recall earlier because um, if people are using a big screen, a big monitor, like a 4K monitor, I'm doing this tutorial on a on a standard monitor. Was it 1920 by 1080? So it's not really that big. But if they're on a big monitor, they don't have to go all the way up to the upper left-hand side to go back to products. They can just click down here. So it saves them a little bit of time. It's just a nice one of those nice things for the end users. Um, yeah, so it's pretty straightforward as to how we implement this. Now, the quote unquote tricky part will be in the metadata function, but it won't be too bad. The meta function in this file is similar to what I've shown you in the previous file, and that is we are going to bring in the data that's loaded from the loader function, and we have two branches of code in this function. So if something doesn't if there are no product, then we can show the static message here. If there are product, then we are going to show them the details in the title, and then apply the meta text description for the SEO bots. So if you think about this, it's actually quite simple. In terms of the title, we already have the title. We're bringing the title back from product. Product has title in it. So all we have to do for title is product.title. And for the product description, guess what? We're actually bringing back the product description already. So that's pretty much it for the meta function. And again, once we have established our component, we have to hook it up to the state manager. In this case, it is the roots file. We have to declare a root. See, I didn't draw my R that time. So we have to declare a root for our component, right? And then we pass in the state, which is products within the products roots, within the product directory, and it will be based on the ID, right? The state is based on the ID of that product. And then, of course, we go to this component here with a dynamic segment. If you worked with Redux, the Redux in the various implementation of it in React, in Angular, you can think of this as the store, right? What is the store? What is the store uh, in Redux? It is a single source of truth for the state, right? So we can think of this as the store for our single source of truth for our state within the React Router component slash remix. Remember, I meant to say React Router app, not component. All right, let's test this out. Let's go down to this one. Let's go to Gucci. Make sure that the name is in the tab. It is. Let's inspect to make sure that it is in the head section. There's the meta tag. Yep, it's our Gucci description. Let's test another one. Let's go back to products. Let's do that one. Okay. Dior. Yep, it's Dior. Do that. Yep, Dior. Let's do one more for good measure. Let's do that one. Let's see here, eyeshadow. Eyeshadow. Yep, eyeshadow. By the way, this product, that's what the API is giving me. I'm not into this stuff, so don't give me any funny looks. Now let's create a component to post data to an API endpoint. The reason I'm calling this component new.tsx is because you follow the roots here. It is in products, new, for add new product. Before we start coding again, I will remind the audience once again that I'm trying to make this app 100% completely server-side rendered, even for posting to an API. Why? Because I'm trying to prove a point. Now, I mentioned earlier that React Router provides a form component. This is a client side. This is a client side component, and it has a lot of very nice features to make implementing a form for posting to an API very simple. And it's a great component to use. However, this will break the 100% server-side render rule for my app. So therefore, I would not use this. Instead, I will use a regular form to maintain 100% single side, server-side render application. If that's not an issue for you, uh, at least for the posting side of things, then you don't have to do this. Let's jump back to the docs real quick. Now, for posting data to an API known as uh, mutation, which includes update and deleting as well, React Router provide server actions. There's also a client action for client-side render application. So the server action, the action function, works similarly to the loader function, except we are sending data to an API endpoint instead of receiving. All right, let's implement this. Let's look at the action function signature. So as you can see there, we are taking in an object, and in that object, there is a request property, which is the HTTP request trigger when the form is submitted. Since this is an async function, we can await the submitted form data. So the await request form data just parses the form, which once it's submitted, we can extract the data from the form fields. That's why it's called form data. Next, we build a product object which we extrapolated from the value in the form fields to include title and price. Then we will send the product object to the endpoint after stringifying it. So I show you the resource on the endpoint earlier in the video for this post request. And then we do a little bit of error checking, and then we send the response on its way. If you've been a developer for a minute or two, this should look familiar to you, right? React Router isn't reinventing the wheel here. We're sticking with what works and robust. Now, you're probably wondering how this action function gets called or gets invoked. Is it invoked in the component? Not directly, but essentially yes. It gets called when a post request is made on the product/new route. So when when a post is made to that root, the library, the React Router library, automatically call this function on form submit. So we don't actually explicitly call the action function, just like in the loader functions. This is why the action function has the export keyword, just like with the loader function has the export keyword. It's been exported so that the library can use it. So quick note about the post product component function, where is taking in an object which has an action data property, and the type will be ID and title. What is that for? That action data is handling what is returning from the API once we've successfully posted a new product. ID, title. Then we will populate our form. The form needs this action assigned to post attribute in order for the action function to be triggered when the form is submitted. Otherwise, this is just an ordinary HTML form. Now, there are some attributes down here to enforce monetary value in that input, but otherwise, it's just your basic HTML form. Now we will build this portion of the HTML in the code, the green part, when success has been returned from the API endpoint. As I mentioned before, we have an action data as a property within this parameter object. So if we posted the form successfully and we get a return ID from the API, we will render this section in the HTML. Okay, simple as that. Obviously, once again, only if the post has been successfully received at the endpoint and the endpoint returns a success object back to us. Before we check for functionality again in the UI, let's go ahead and implement the meta function for this. It should be easy to do because it's just static. Now, if you want, you can do something fancy here. I've given you enough knowledge to do that. Configure the root, the state, and the component in your root file. Now, before you test it out in the UI, make sure that you apply the Tailwind CSS class names for your styling. Otherwise, you don't get any styles, CSS style here, and it'll look all janky. Okay, so let's test this out. Make sure we have it right here. So test one, $11.77. Yay! And we have our metadata as well. So off screen, I've added another component root inside of the roots directory. Nothing we haven't seen before in terms of file structure. And of course, I've added the catch-all root. The root for catch-all is an asterisk, right? Because it's, catch-all wildcard. Now, the question is, why am I adding a catch-all root for errors for force when in the root file that comes with the library, it's auto-generated by the library, there is already an error boundary. The answer is this. So we know that we have a slash products root in our application. If I were to type something crazy in here with another forward slash, say forward slash bacon, because this part of the UI is legit, it's going to take me to the root file error boundary portion of the app. It's going to hit that for there. Now, if I were to say products ZZZ, which does not exist anywhere in the app forward slash bacon, is going to hit uh, my custom 404 page in the catch all route, right? Because the application is not catching this particular route because it's unknown. That's why it's called catch all. And if you're curious, the meta does work. Uh, we should see, there's the Taylor Swift message for our custom metadata. I should also mention that if you want to add a button here to redirect the app back to the products page, like I'm doing up here in the link, that'll be a nice little challenge for you. I've certainly given you more than enough knowledge to do that. Now we need to cover deployment to Vercel. Now, unfortunately, with Vercel, you do not have an option to install the Vercel CLI inside of the project directory at the project folder level. You have to install Vercel CLI globally on your computer. Now that will certainly turn some people off. You certainly have the option of doing this in some sort of container. Okay. All right. So after knowing that, if you want to continue, here's how you can do it with Vercel. So obviously you need to sign up for a free account with Vercel. Their free tier is very generous, I will have to say. And then you sign up for a free tier account and you set up the Vercel CLI on your computer. Again, I do have a pre-made completed React Router v7 app that's meant for Vercel. I spun up this application using this command here provided by React Router. So with Vercel, you do have to push your code, not necessarily your completed code, but your code to GitHub or some sort of Git vendor of your choice. And then in your Vercel UI at the website, you have to create a new project. And then you would link the new project with your GitHub repo, GitHub or Bitbucket or whatever you use. Additionally, in the Vercel UI or website, you have to change the output directory in the settings. You have to change the output directory, flip these sliders to enable, and you have to type in bill/client. If you don't do this, you're going to get an error. And once you've done all of that, once you set up your CLI command line tool, set up your account, set up your project, um, you can run these commands here. Now, these command, the Vercel build and the Vercel dash prod, that's in the documentation. I have aliased those command inside of the scripts object so that I can issue this command from the command line using pnpm. Now, when you first run build, when you build, it might ask you to connect to your project in the Vercel GUI, in the Vercel UI in the website. Then you would enter the name, whatever name you name that project, you have to enter it into the command line. Only then will you be able to deploy it from the command line without having to push to GitHub. Okay. Yeah, I know that's a lot of work. I don't know what to tell you. That just it is what it is. Now for React routers application that are deployed to any cloud vendors, if you are seeing this in your Chrome developer console, where it says no routes match the location and it gives you this path, you might also see this in your CI CD pipeline logs. It might show up as an error. It's definitely going to show up as an error in your terminal when you use the Chrome DevTools. The reason is because the Chrome DevTools is, for lack of a better term, choking on this package from React Router here, the dev package. Okay. The way to overcome this is to create a .well-known directory inside of your public directory, and inside of your .well-known directory, create another directory called appspecific. And then inside of there, you are going to create a file, a JSON file called com.chrome.devtools.json, and then give it the empty curly braces and then save. That should take care of your local error in the terminal. And then if you push it up to your repo, it'll take care of the error that's happening inside of your CI/CD pipeline if it's happening. This concludes this video tutorial, my dear friends. Please subscribe to my channel. It's free, doesn't cost you anything whatsoever, and down the road in the future it's going to help me out. Again, thank you for watching, and I'll see you next time. Goodbye for now.